R32 is a mildly flammable refrigerant classified as A2L, with a very low risk if the gas is handled properly, and if the equipment with R32 is installed and maintained adequately. However, cases of explosions of this gas have been reported without an apparent explanation. In this video, we will study the possible causes of these accidents. Let's start by saying that the auto ignition temperature of R32 is very similar to R410A at around 700 degrees Celsius. We can analyze that since accidents occur with R32 gas and not with R410A, this indicates that the cause of the explosion is not precisely the auto ignition temperature. Now let's remember that both R410A and R32 work with POE oil, so apparently this is not a differentiating factor on its own for the cause of accidents with R32. It is important to analyze the type of lubricant used by both gases, as it has been shown that, in the presence of air, POE lubricating oil can ignite under high compression conditions, and in the presence of points with extremely high temperatures. This is precisely where the difference lies. R32 reaches higher temperatures at hot spots compared to R410A. For this reason, although both refrigerants use POE oil, the mixture of oil and air inside equipment operating with R32 can ignite more easily, which could then internally ignite the R32 refrigerant and cause a sudden increase in pressure and temperature in the system. In fact, without the presence of oil, this combustion does not occur. Tests have shown that a mixture of R32 refrigerant and air without oil does not ignite under any circumstances. This indicates that the explosions are more related to the high discharge temperature of the compressor when working with R32 than to the flammability of the refrigerant gas itself. Therefore, the critical factor is the presence of hot spots, and this is the true root of the problem. Now let's analyze the points of highest temperature in the refrigeration system. The discharge temperature of R410A is normally estimated to be around 85 degrees Celsius, with variations of up to 20 degrees Celsius under abnormal equipment operating conditions. In the case of R32, the gas temperature at the compressor outlet, under normal conditions, is usually in the range of 100 degrees Celsius to 110 degrees Celsius, but it can increase significantly if abnormal conditions arise. The problem occurs when operational failures happen, such as A. Low refrigerant charge, which causes overheating due to insufficient pressure in the evaporator. B. High pressures in the condenser, caused by blockages or poor ventilation. C. Both conditions can cause the discharge temperature to dangerously approach the ignition temperature of the oil, although it is still far from reaching the auto ignition temperature of the refrigerant. D. In compressors that use flammable refrigerants like R32, if high discharge temperatures are combined with the presence of air, oxygen, in the system, the oil can reach its ignition point or even auto-ignition, which can trigger an explosion inside the compressor. The explosions are not due to the direct flammability of the refrigerant, but to the presence of air, oxygen, and hot spots that act as an ignition source. However, for an explosion to occur, in addition to hot spots, there must be oxygen or air inside the system. Let's see what can be done about it. Air or oxygen enters the refrigeration circuit mainly due to poor practices during installation or repair. The most common causes are A. Insufficient evacuation or no vacuum gauge. If a deep vacuum, ideally equal to or less than 500 microns, is not performed, air remains trapped inside the system. Technical guides recommend using a vacuum pump and a digital vacuum gauge to ensure proper evacuation, especially to maintain the vacuum below 500 microns. B. Air or oxygen should never be used to purge or pressurize the lines. The correct procedure is to purge with dry nitrogen, an inert gas, before and during brazing. C. A faulty vacuum pump or a manifold gauge or vacuum gauge with incorrect readings can prevent achieving an adequate vacuum. Without a good vacuum gauge, it is not possible to verify the actual vacuum, which can lead to a false vacuum and leave air in the system. The final vacuum must be below 500 microns. Now let's look at the factors that raise the discharge temperature. A low refrigerant charge causes overheating of the refrigerant at the evaporator outlet. Furthermore, due to the low gas charge, a low pressure is generated in the evaporator. This forces the compressor to operate at a high compression ratio, which increases the discharge temperature. B. An overcharge of refrigerant raises the condensing pressure, which causes the compressor to draw more current and generate more heat. C. A dirty condenser with bent fins or poor ventilation reduces its ability to dissipate heat, which causes an increase in pressure and discharge temperature. D. A partially clogged capillary tube, filter, or pipe generates high back pressure and low evaporation, which increases superheat and discharge temperature. E. Loose electrical connections can cause overcurrent and overheating of the motor and compressor. F. The oil, in addition to lubricating, also serves to dissipate heat. Its scarcity or degradation increases the internal temperature and the risk of carbonization. Always use the type of oil recommended by the manufacturer.